Imagine you open your browser, you type google.com, you press enter. Less than a second later, the website appears. Simple, effortless, almost instant. Most people believe their computer already knows where Google is. But stop for just a moment. How could it? The internet contains billions of websites. Millions are added every year. Yet somehow, your request always finds exactly the right one, without hesitation, without getting lost, without asking you for directions. So here's the question. When you type a website name, who actually knows where to find it? Because computers don't understand names. They understand numbers, which means before any website can appear, something else must happen first. A silent conversation, hidden from your screen, invisible to almost everyone, yet repeated billions of times every single day. Today, we're uncovering one of the most important systems ever built for the internet, a system so reliable that most people never realize it even exists. Because before the internet can find any website, it must first answer one simple question: where?
Imagine meeting someone for the first time. They tell you their name, not their address, not their location, just their name. Knowing the name doesn't tell you where they live. Before you can visit, you need an address. The internet works in much the same way. When you type google.com, you're not giving your computer a location. You're giving it a name designed for people, because names are easy to remember. Numbers are not. Most people think website names are where the internet begins. Architects know names are only the beginning of the journey, because computers don't understand Google or YouTube or Wikipedia. They understand addresses, numerical addresses, unique addresses, addresses that tell the network exactly where to go. Without them, the internet would have no destination. Every website would simply become another name, with nowhere to send your request. Which means every time you type a website, someone, somewhere, must quietly translate that human-friendly name into something computers can understand. A translation so fast you never notice it happening. But who performs that translation? And how does the internet always seem to know the answer?
Imagine you want to visit a friend. You know their name, but not their address. What's the first thing you would do? You'd ask someone who knows. The internet does exactly the same thing. The moment you type a website name, your device doesn't guess. It asks, quietly, automatically, almost instantly. Not asking the website, but asking a system designed to know where websites actually live. Most people have never heard its name, yet they depend on it every single day. It's called the Domain Name System, or simply DNS. Imagine the world's largest phone book, not filled with phone numbers, but with website names. On one side, names people remember. On the other, numerical addresses computers understand. Every time someone types a website, DNS quietly looks for the matching address. Once it finds it, the answer is sent back. Only then can the journey continue. Most people believe typing a website immediately opens it. Architects know the first destination isn't the website, it's DNS. Because before the internet can go anywhere, it must first know where there is. But another question immediately appears. The internet serves billions of people every second. How can one system possibly answer so many questions without slowing down? Imagine one person answering every phone call on Earth. Impossible. The calls would never stop. The waiting would never end. DNS faces the same challenge. Every second, billions of people ask the same question. Where is Google? Where is YouTube? Where is Wikipedia? Where is ChatGPT? If every request had to ask one computer, the internet would quickly slow down. That's why DNS was never built as one server. It was built as a global system. Thousands of DNS servers distributed across the world, working together, quietly sharing the workload. Imagine walking into a library. Every visitor asks for the same book. Instead of sending everyone to one librarian, the library places librarians throughout the building, each one helping the people closest to them. The result is simple: less waiting, faster answers. The internet uses the same idea. Your question doesn't travel around the world if it doesn't have to. It finds the nearest answer available, making every website feel almost instant. Most people believe the internet is fast because websites are fast. Architects know the internet feels fast because systems like DNS were designed to remove unnecessary delays. But answering the question is only half the job. Once the address has been found, something else must decide how to reach it. And that's where the next hidden system quietly takes over. Imagine someone gives you an address. Does that instantly take you there? Of course not. Knowing the destination is only the beginning. Now you must choose the road. The internet faces the same decision. DNS answers where. Another system answers how. How should your request reach its destination? Which path is the fastest? Which route has the least traffic? Which connection is still available? Every second, those questions are answered again and again and again. Most people imagine the internet as one giant highway. Architects know it's millions of interconnected roads. Some are busy, some are quiet, some become unavailable, others immediately take their place. Every request quietly searches for the best path available at that moment. Not yesterday, not an hour ago, right now. Imagine driving home. You discover one road is completely blocked. Do you stop? No, you simply take another route. The internet does exactly the same thing. Most people never notice when one connection disappears because another path has already taken over, quietly, automatically, within moments. That's why the internet feels so reliable, not because nothing ever changes, but because the network never stops adapting. But even finding the right path still isn't the end of the journey. Because eventually, your request arrives. at the destination. And for the very first time, someone must answer. By now, the journey is almost complete. A name has been translated. An address has been found. A path has been selected. Across networks, across cities, across continents, until finally your request arrives. Not at the internet, not at the cloud, but at a computer, waiting to answer. That computer finds the information, prepares the response, and sends it back, following another journey across the same invisible infrastructure. All of it happens before you even notice the page has finished loading. Most people think a website appears the moment they click. Architects know the click was only the beginning. Behind every click exists a conversation between systems, between networks, between machines, quietly working together to answer one simple request. Not once, but billions of times every single day. That's why the internet feels effortless. Not because it's simple, but because its complexity has been carefully hidden from everyone who uses it. And perhaps that's the greatest achievement of modern engineering. The more complex the system becomes, the simpler it feels. Most people type a website. Architects see a journey that begins with a name, finds an address, chooses a path, reaches a machine, and returns with an answer. Because the internet never guesses. It always finds. Once you understand that, you stop asking, why did the website open? You begin asking, what invisible systems worked together before I ever saw the first page? Because every digital experience begins long before the screen changes. It begins with architecture. This is NextNet, inside the modern internet.